So, have a nice day everyone. This video is about my activities here in chapter 5. So, this chapter was entitled as the Ethernet. So, watch this. Let's start. First, we will launch course. So, we will go in chapter 5 and we will find these the activities. So the first activity was located at page 5.1.1.5. So this activity was entitled as the MAC and LLC sublayers. So when we say MAC, stands for Media Access Control, which is implemented in hardware. It is typically in the computer network interface card. So when we say LLC or the logical link control sublayer, it is implemented in software and its implementation is independent on the computer hardware. So let's start. The instructions of this activity is descriptions of the MAC and the LLC sublayers are provided in the table. Click into MAC or LLC fields to match the descriptions to the correct sublayer. So, it first controls the network interface card through software drivers. So, it is the LLC. Next, works with the upper layers to add application information for delivery of data to higher level protocols. So it is LLC also. Works with hardware to support bandwidth requirements and checks errors in the bits sent and received. It is the LLC sublayer. It controls access to the media through signaling and physical media standards requirements. So it is the MAC or Media Access Control sublayer. It supports Ethernet technology by using CSMA or CD or the CSMA or CA. So it is also a MAC. Remains relatively independent of physical equipment, so it is LLC. Works with hardware to support bandwidth requirements and checks errors in the bits sent and received. So I'll change the answer to MAC. Let's check it. It's all correct. Okay, next we will find the next activity, which is located in page 5.1.1.6. So, it is entitled as the Identify Ethernet Frame Field Names or Ethernet Frame Fields. So, drag the 802.3 Ethernet frame field name to its description. So, we will put the field names here to its corresponding description. First, uses pad to increase this frame field to at least 64 bytes. So, it is the 802.2 header and data. Next, it describes which higher layer protocol has been used. So, it is the type. The frame's originating network interface card or the NIC or interface MAC address is the source address. So next, assist a host in determining if the frame received is addressed to it. So it is the destination address. It notifies destinations to get ready for a new frame. It is the preamble. Synchronizes sending and receiving devices for frame delivery. So, it is the start of frame delimiter. And lastly, it detects errors in an Ethernet frame So it is a frame check sequence. So let's check it. So okay, next we will proceed on the part 2 of this activity. So drag the Ethernet frame field name to its correct location on the diagram. So first is the 7 bytes. It is the preamble. 1 byte is the start of frame delimiter. Next is the 6 bytes. It is the destination address. Next, 6 bytes also is the source address. Next is the 2 bytes, which is the length. Next is the 46 to 1500 bytes is the 802.2 header and data. And lastly is the 4 bytes, the frame check sequence. So let's check it. It's all correct. So now we will proceed on the next activity, and we will find the next activity here. So the next activity is located at page 5.2.1.6, which entitled as the switch it. Determine how the switch forwards the frame based on the source MAC and destination MAC addresses and information in the switch MAC table. Answer the questions below using the information provided. So, the source MAC address is the 0B and the destination MAC address is the 0A. So, first question, where will the switch forward the frame? So, the source is the 0B and the destination is the 0A. So the switch will forward the frame at 0A. Let's and next is when the switch forwards the frame, which statements are true? Frame is unicast frame and will be sent a specific port only. So let's check if it's correct. So the question 2 is incorrect. So we will check also the switch adds the source MAC address to the MAC table. Let's check. So it's correct now. So we will find or answer the new problem. The source MAC is the 0F and the destination MAC is the 0C. So the source is the 0F and 0F is located at FA9 and the destination is 0C. So we will try to answer these. Destination is 0C, which is in FA5 or port 5, and we will try FA5 and specific port only. So okay, next we will find the next activities, which is located on page 5.2.2.4, which entitled as the frame forwarding methods. And the instruction is descriptions of switch frame forwarding methods are provided in the table. Click the store and forward or cut through fields to match the methods to the description. So, when we say store and forward switching, it is the one who receives the entire frame and it computes the CRC. While when we say the cut through, it is the one who forward the frame before before it is entirely received. So, let's start. Buffers frames until the full frame has been received by the switch. It is the store and forward. Next, checks the frame for errors before releasing it out of its switch ports. If the full frame was not received, the switch discards it. So it is the store and forward. So next, no error checking on frames is performed by the switch before releasing the frame out of its ports. So it is the cut through. Next, a great method to use to conserve bandwidth on your network. It is the store and forward. Next, the Destination Network Interface Card or NIC discards any incomplete frames using this frame forwarding method. So it is the cut through. And last is it's the faster switching method but may produce more errors in data integrity, therefore more bandwidth may be consumed. So it is the cut through. So let's check. It's all correct. Now we will proceed on the part 2 of this activity. Read the scenario based on the topology shown. Identify how the frames will be processed by dragging your answers to the appropriate fields provided in the table. All answers will not be used. So, first, cabling used in this topology will be the straight through. Next, to find where PC2 is located, PC1 will send out a broadcast data frame. The PC2 will respond back to PC1 by sending back a blank message. So it is the unicast. PC2 will respond back to PC1 by sending back a unicast message. And next is if PC2 receives only half of the data in the frame, it will discard it. And lastly, if PC2 receives many damaged frames on port 3, S1 likely will change back to the store and forward switching. So let's check. It's all correct. So we will find the next activity if there is more activity. So in this, I think there is no next activities. So that's all and we will return to class. So thank you for watching this video and I hope you enjoy and understand this and I hope you learn from this video. So thank you for watching. I'm Kisha Lyka Villanueva of IT 2105.